Now we're going to tackle our second type of problem, which is finding a formula for f inverse of x. So, given a formula for f of x, how do we find a formula for f inverse? So we start with the formula y equals f of x. We know that that's equivalent to the formula x equals f inverse of y. So whenever y equals f of x, we must have x equals f inverse of y. We can use the following method. We can start with our formula y equals f of x, and if it's possible, then solve for x in terms of y to get the formula on the left here, x equals f inverse of y. And then because we prefer to have a formula of the form y equals f inverse of x, we can just take this equation and switch the roles of y and x to get a formula of the form y equals f inverse of x. Let's apply this. Suppose we start with f of x equals 2x plus 1 over x minus 3. You'll have to take my word for it that this is a one-to-one function, and let's find a formula for f inverse of x. In the equation y equals f of x, or y equals 2x plus 1 over x minus 3, our first step is to solve for x in terms of y. In order to do that, we're going to multiply across by x minus 3, and we get x minus 3 times y equals 2x plus 1, which gives us this equation, x times y minus 3 times y equals 2x plus 1. Now we want to solve for x, so the first step in doing that is to bring all of the terms with x to the left-hand side and bring all of the other terms to the right. And now we can pull out an x on the left-hand side, and we get x times y minus 2 is 1 plus 3y. And we can now express x in terms of y. If we divide across by y minus 2, we get x equals 1 plus 3y over y minus 2. So now we have an equation of the form x equals f inverse of y, and that's 1 plus 3y over y minus 2. And if we want to make the independent variable x and the dependent variable y, we just switch the roles of x and y in this equation. So we get y equals f inverse of x is the same as saying that y equals 1 plus 3x over x minus 2, or f inverse of x is 1 plus 3x over x minus 2. When do we need a formula for f inverse of x? As we saw previously, we don't always need the formula for f inverse of x in order to find a value of f inverse at a specific value of x. So recall in our previous examples, we had f of x is x cubed plus 1, g of x is cosine of x plus 2x, and we didn't need a formula for f inverse in order to find f inverse of 28, or g inverse of 1. And this is especially useful to keep in mind when you're dealing with functions such as g of x here, which is cosine of x plus 2x, where it's very difficult to solve for x in terms of y in the previous method.